Ever wondered how AI transforms a text prompt like a lively jazz tune with a saxophone solo into a full musical composition? That's the magic of text-to-music generation, and today we're diving into a groundbreaking study comparing two core approaches: auto-regressive AR models and flow-matching FM models. Let's unpack what makes these systems tick and why their differences matter. First, let's set the stage. Text-to-music isn't just about spitting out notes. It's about capturing the nuance of human creativity. But here's the catch. There's no single best way to build these models. Some systems use AR, where the AI predicts one note at a time, like writing a story word by word. Others use FM, a modern technique that flows through possibilities all at once, like sketching a painting before filling in the details. So what's the big deal? The researchers wanted to know which approach is better and why. To find out, they did something bold. They built identical models except for one thing: the core algorithm. Same training data, same architecture, same audio codecs. The only variable: whether the model was AR or FM. Imagine two chefs cooking the same recipe, but one uses a slow, methodical technique while the other experiments with a faster, more flexible method. That's what they did here. By isolating the modeling paradigm, they could see how each approach handles key challenges. Fidelity: how well does the music match the text? Control: can the AI follow complex instructions like chord progressions? Speed: how quickly can it generate music? Flexibility: can it edit existing audio like fixing a bad note? The results? Let's break it down. AR models shined in perceptual quality. They produced music that sounded more natural and coherent, especially when following tight temporal cues like chord changes. But they were slower, especially when handling large batches of data. Think of them as meticulous composers who take time to perfect every note. Flow-matching models, on the other hand, were faster and more adaptable. They could generate music in a fraction of the time and handled edits like audio inpainting, fixing missing parts better. However, their output sometimes lacked the smooth transitions of AR models, like a painter who's quick but occasionally misses the brushstroke. Here's where it gets really interesting. AR models kept improving as they trained longer, while FM models hit a ceiling earlier. That suggests AR might be better for tasks requiring fine-tuned control, like composing complex symphonies, while FM excels at rapid prototyping or real-time applications. So what does this mean for the future of AI music? There's no one-size-fits-all solution. If you want hyper-realistic, emotionally resonant music, AR might still be the way to go. But if you're building a tool for quick edits or interactive experiences, FM could be your secret weapon. Now, let's zoom in on the inner workings of these models. Imagine you're listening to a song, but suddenly there's a glitch, like a few seconds of silence in the middle. What if an AI could fix that? Well, researchers are teaching machines to do exactly that, and it all starts with something called a latent representation, the AI's internal snapshot of sound. Think of it like a mental image a musician holds before playing a note. But here's the twist: there are two different ways this snapshot is created. One method, auto-regressive models, works like writing a sentence. The AI generates sound one piece at a time, building up a melody step by step. The other, flow-matching models, is like reverse engineering a song from scratch, starting with random noise and refining it into music. But here's where things got tricky. When they tried using raw, unfiltered data, like a messy room full of clutter, the AI struggled. So they built a special tool called an autoencoder, which cleans and organizes the data, much like how you tidy up a space before starting a project. Now here's where it gets really cool: inpainting. Imagine a song has a missing section, maybe a few seconds of silence. The AI can fill that in like magic. By understanding the structure of music through these latent representations, it can predict what should be there. It's not just about fixing glitches. It's about teaching machines to understand sound in ways that feel almost human. And the best part? This tech could revolutionize everything from music production to restoring old recordings. Next time, we'll dive into how this same tech is helping doctors analyze medical scans. But for now, what do you think? Could AI ever create art that moves us as deeply as a human masterpiece? Let me know in the comments.